Hi guys, B-Dog Maths here and I'm B-Dog again. I've been given a problem to work with, a problem known as proofs. It's a high grade GCSE topic, so you're talking grade 8 or grade 9 on the new syllabus, maybe a grade A start on the old syllabus, even though it's going to be old so you don't need to know about it anymore. Yeah, it's a difficult one because it involves you using lots of different skills combined together, and the guidance in that skill is pretty much not there. You will see two main words in the question to know that you're dealing with proof. You'll see those two, show and you'll see prove. If you see those, you tend to know you're in that realm of GCSE that is going to involve you to structure your work out well and use linking words, use linking terminology to help you answer your problems. Okay, so that's key. So we're going to work on now just the terminologies required for this activity. Then I'll throw a question up on there so you can see. Pause me, write that question down. I'll come back to you and I'll show you how it should be solved using these words correctly, and hopefully give you a more flavour to how proof is done. And actually, that if your algebra is good, your proof will be good as long as you understand the words. Okay, so let's write down a list of words that will help you sort this problem out. Hey guys, so hopefully you've got some pen or pencil and paper ready to have a go yourself. But as you could see from that piece of paper, I had some space for some more words, yeah? So I've got more words for you to think about. In the question we looked at show and prove and the difference between those two levels. There's also four other words that I see come up quite frequently. They are consecutive, odd, even and multiple. Now, odd and even, I think you should know by now, even though explaining what they are is difficult. So an even number, first of all, is a number that's a multiple of 2, that is in the 2 times table. Yes, that sounds simple, but under pressure, to remember that definition is very difficult. Odd number is a number that is not in the 2 times table. So if you think about it, every odd number follows directly after an even number. So 3 follows 2 or precedes 4. So you can see there's a pattern there. We're going to use that pattern today. And you're going to use that pattern quite frequently if you do proof questions. And then you have the word multiple and what that actually means. A multiple of 3 is something that is in the 3 times table. So it can be written as 3 times something. Like if you want to look at that again, remember my Know Your Times Tables video. That is where I'm going there. And the word consecutive, well, that one is a big, it means to follow on or to be next to or the next one along. So 3 follows 4, 4 follows 3 if you're talking about consecutive whole numbers. You can talk about consecutive square numbers and then you're talking about 16 and the next one being 25. Consecutive odd numbers, you might be talking about 19, then 21. So consecutive means the next one's in line. So all the questions, you're going to have those words in there and they're quite important to understand. Then in your answer section, there's going to be words and linking terminology that you're going to really look to grasp and use. And they are the words let, so, then, and therefore. And there's a little symbol for therefore, which is there's 3 dots, dot, dot, and dot, in that sort of triangle. Well, that means therefore, and that is accepted in exams. It is accepted. So here are all those words. Feel free to pause and get them written down. Cool. All right, in. Let's get ready for this question. Okay then guys, so we are here now and it's about to work on that first question. So the question is going to come up shortly. Look at the question, copy it down, pause me if you need to pause me, and then when you're finished copying it down, you might want to have a go yourself first, but then come back to me and we'll go through it together. Okay, here's the question. Okay then folks, so we have this question here. Prove that the sum of any 2 consecutive odd numbers is always even. The first thing you need to do is to understand what's being asked of you. So I then do like a bit of an underlying situation, starting from the end of the sentence, coming backwards. So Prove that the sum of any two consecutive odd numbers is always even. So my solution needs to show that it's even. That's quite an important thing. So I need to show that my answer ends up being even somehow. I'm working with odd numbers, okay? Odd numbers. They are consecutive, which means next to each other, as we've already discussed. We're only dealing with two of these numbers, and we're trying to work out that the sum of those. So that means adding them together. So going forwards, I need to add two next to numbers that are next to each other and happen to be odd. So 3 and 5, 7 and 9, and so on. But I can't just choose numbers, because that's not proving it. That's just showing that it works somehow in some situations. I need to prove that it works in all situations. So the first thing I need to do is I need to set up the situation so it works. Alright, so we know that even numbers are also multiples of 2 in the 2 times table. So we need to remember that our answer needs to show this. Okay, folks? So remember, no point doing all this work if our answer doesn't show this. We start off with this setup of the situation. So we start with the word let. We're going to let any letter that we use. We tend to use n all the time, but you can use a different letter if you wish, x or p or whatever. Let n be an integer. An integer, we should know now, is a whole number. Right? It's commonly used in proof, a whole number. So we're not talking about decimals, we're talking about a whole number. And the reason why I'm using that is because I can change this now into a definite odd number. First of all, though, to change it into an odd number, I first need to change it into an even number by multiplying it by 2. Anything multiplied by 2 is an even number. So n multiplied by 2 will be an even number. Now I know that the number after this one, plus 1, will have to be odd. That is fact. If I've got a number that is even, I know the number next to that number is going to be odd. So that's 2n plus 1. And from that, I know that 2n plus 3 will be the next number, which is odd. So now I've got 2 consecutive odd numbers. There we go, 2 consecutive odd numbers. I now just need to do this one here, which is sum it up, add them together, and hopefully show that they are even. So there's all my points covered here. Right, so how do I add these together? Well, first of all, I write it down. That's what I'm going to do. 2n plus 1, add that to 2n plus 3. Equal sign nice and neatly somewhere so I can denote when my next line is starting. And I have 2n, add 2n is 4n. 1n plus positive 3 would give me positive 4. Again, I'm looking at that, I see that both of these numbers are in the 2 times table. So I'm going to actually write it down, and that's saying 2 times something will give me this answer. And with your factorization skills, you should know that 2 lots of 2n will give me my 4n, and 2 lots of 2 will give me my 4. Therefore, the sum is indeed a multiple of 2. Thus will always be, this marker pen will always be even. Boom, answered. Hope you've enjoyed that. Speak to you again in a bit. Hey, so that's it really. Hope you enjoyed that. I hope you found it useful. If you didn't enjoy it, but I hope you found it useful. It can get a little bit more tricky than that really. I mean, it can be hidden in a shape where you have to show that they equal 180 degrees, or you need to know that they equal 180 degrees, or that the 2 consecutive numbers would first need to be squared before you add them together, before you show that they're a multiple of either 3, 4, 5 or some other number. But the principle is the same. So idea of proof. If you've got a problem with proof, you've got a problem with setting up the situation. You haven't got a problem with algebra, you've got a problem with proof. If you're struggling with how to go about doing the problem, then that's a problem with algebra, which is another story, and that's something that you need to work on separately. So don't get confused. Proof is the setting up and the structure of how to get from one place to another algebraically, whereas if you've got a problem with factorising or expanding or things like that, then that's another issue to deal with. And again, if you need help with those things, folks, just make a comment below, like the video, make a comment below, and I will get back to you showing that. So this is me, B-Dogs Maths, saying, see you later.